right, so now we're going to talk about concavity. You see those two pictures? The first one looks like a parabola is down. The second one looks like a parabola is up. The first one, if I poured water in, it wouldn't hold the water, right? So we call that concave down. The second one would hold water. We call that concave up. It turns out that the concavity of a function is connected to its second derivative. So when a function is concave down, the second derivative of the function is less than 0. If a function is concave up, the second derivative of the function is greater than 0. Could I add a part D to my test question now? Tell me when the function's concave up and concave down. And you would have to use what derivative? Second derivative. Okay, we'll talk about why that's the case in just a minute. A point where f of x changes, excuse me, concavity and there is no vertical tangent. Squeeze it in. Is called an inflection point. So if you have a point where the function changes from concave up to concave down, or concave down to concave up, and there's no vertical tangent, so there's no asymptotes or anything there, then that's called an inflection point. In general, inflection points occur at f double prime of x equal to 0 or undefined. But you still have to check. That's why I say in general, because it still has to satisfy the definition of an inflection point. That has to be a place where the function changes concavity. All right? But in practice, what you would do is find the places where the second derivative is equal to 0 or undefined, then go back and check to see, is that a place where it changed from concave up to concave down? So the tool that you're going to use will be your sign chart again. And this time it's going to be on the second derivative. Because that's the one that you're trying to find out when Shelby is going to put it on Instagram, if it is greater than 0 or less than 0. It's just a week left, so I don't, y'all just tweet, Gram, chat, Snappy Chat, whatever y'all want to do. Put on the Snappy Chat. Just put me on there, Martino. I want to be on your Snapchat. All right, so you took the second derivative. And you got this. After you factored it and did all your thing, right? My assumption is, Michael, that everybody can take a second derivative. So God bless you, okay? And you got this, and somebody asks you, where is this function concave up? What you gonna do? Where is it concave down? What you gonna do? What do you need? You need a sign chart, right? So the first thing you'll do is take that second derivative, you're gonna make a sign chart for it. Where is it equal to 0? Where else? Okay, you're going to list your factors. To the left of minus 1/2 is 2x plus 1, negative or positive. Plug in minus a million. 2 times a minus a million plus 1, is that negative or positive? Y'all too slow. 2 times minus $1 million plus 1. Is that negative or positive? Thank you. At minus 1/2, what is it? Come on. Yeah, hello. We plug minus half, it's 0, right? Come on. To the right of minus 1/2, it's got to be plus because it's a linear factor, but you can check test values over there. Okay, what about x minus 5? That's going to be 0 at 5, right? Click something to the left of 5. What is it, negative or positive? Minus $1 billion minus 5. Is that negative or positive? Thank you. So it's a linear factor, so to the right it's got to be positive. 2 minuses make a what? On the left-hand side of minus 1/2. 2 minuses make a plus, right? Hello? Yeah. Okay, so the second derivative is positive over there. In between minus 1/2 and 5, a negative and a positive makes a negative. To the right of 5 is 2 positives makes a positive. Where is this function concave up? What are the regions? Give them to me. Concave up. Too slow. Negative infinity to negative 1/2. Good. Union. 5 to infinity. Concave up. Where's it concave down?
Negative 1/2.
Assuming that there are no asymptotes, I didn't give you the function, so you really can't analyze. But assume there are no asymptotes or vertical tangents. Where are or is the inflection point or points if they occur for this function? Inflection where? Okay, good. So inflection at x equals minus 1/2. X equals 5, and if you had the function, you could find the point because you could plug in the x and find out what the y was, right?
So
but
this would be like, by default, it would be.
By default, when you say by default, I don't know what that means. Like by
Those are the only points you work for. So those are your equations.
those are the only possible places, right? Because an inflection point occurs where? What's it? Where the second derivative changes from plus to minus. And what does that really mean physically? That's where the function does what? Changes concavity, right? So if the function changes concavity and you don't have a vertical tangent, then that's called an inflection point. And you see that from your sign chart. If you can't do the sign chart, you're never going to get the first derivative part right or the second derivative part right. This is a tool. It's like not being able to multiply. So, yes, Ashley?
So, I have a question about the sign chart. What do you plug in on the second row? You know what I'm saying? Like where you got negative, and then positive.
You can plug in anything you want to in that.
I know, but.
So plug something in. Plug something into the left of minus 1/2.
But that's how you get the first row.
That's how you get the second row too.
Oh my gosh. I'm sorry.
Yeah.
What did that say?